Hi dear students, welcome to my class on periodic properties. In this class I would like to discuss about all the periodic properties. The first one is atomic radius, second one is ionization enthalpy, third one is electron gain enthalpy, fourth one is electron negativity, the fifth one is electropositivity. So this is the list of important periodic properties under the board syllabus we have. And as first one, atomic radius, we'll see. It is the actual distance between the nucleus to the center of the nucleus to that of outermost electron in isolated gaseous atom. You should remember that one. And when it comes to practicality, the telling it cannot be measured because electron density goes up to the infinite distance. So there is no boundary of this electron cloud. That's why the measurement of atomic radius is something impossible. But we have some alternate atomic radius to understand the size of atoms. They are, one is covalent radius, another one is van der Waals radius, the other one is metallic radius. In this, various types of atomic radius you see. The first one, what I have discussed, is covalent radius. It is one kind of half of the distance between the nuclei of two atoms of same element bonded through a single covalent bond. But here, if you take chlorine molecule, the distance between two nuclei of two atoms of chlorine, if you take 198 picometers, then distance of the 198 is 99 picometers will be the covalent radius of chlorine. Now in this one diagram, if you observe in this, the distance between the two is d taken, then our covalent radius will become equals to d by 2. And in this another diagram, we have two chlorine atoms are joined 198 picometers covalent diameter, that we call covalent bond diameter distance. And the calculation, if you see here, 198 by 2 is 99 picometers, which is covalent radius. Whereas the van der Waals radius, when you see, it is the half of the distance between the nuclei of atoms of same element which are non-bonded and belong to adjacent molecules in solid state. Generally, van der Waals forces of attraction are much lesser than the covalent bond. That's why distance will be more in this case. And that's why van der Waals radius is greater than covalent radius. The diagram, as you observe here, in this diagram we have non-metal discussion is there. In this also chlorine molecule, one chlorine molecule 99 picometers shown, which is covalent radius, but different atoms from different molecules 360 picometers is the d shown. That d by 2 is the van der Waals radius. 360 by 2 is 180 picometers is the van der Waals radius of chlorine. Let us move on to the next one, this metallic radius. Metallic radius also called as crystal radius. It is also half of the distance between the nuclei of two atoms of metal core in a metallic crystal. In copper metal, the distance between the two copper metal atoms is 256 picometers. So the metallic radius of copper is 128 picometers. We have see our metallic is d by 2. The diagram, as you observe, it is d by 2. Now we have order of atomic radii. How these three atomic radii are related, we'll see. First of all, van der Waals radius is the bigger one of that metallic or crystal radius. Next we have covalent radius. That means it's a decreasing order of this atomic radius. Van der Waals radius is greater than metallic crystal radius is greater than covalent radius. Okay. Now the diagrams, when you observe this van der Waals radius, distance apart here more, closeness is less in case of metallic radius, and very close they are in case of covalent radius. That's why when the distance is decreasing, then radius also decreases. That means the distance, van der Waals distance is more than metallic radius. Metallic radius distance is more than covalent radius. Thank you. Go to the next one here. We have factors determining atomic radius. The one is nothing but atomic radius depends on two factors. The one is nuclear charge. The other one is screening effect or shielding effect. Let us see what is nuclear charge. Nuclear charge is nothing but As a nuclear charge is actually nucleus influence only. Protons influence up to what distance is there. More protons are there, more is the nuclear charge. But if outer electron is close to nucleus, nuclear charge also will be more. So in this, electrons will experience more attractive force if nuclear charge is more, and from the nucleus, and electron cloud shrinks. That's why inversely proportional atomic radius. That means nuclear charge increases, size decreases. Nuclear charge is inversely proportional to atomic radius or size. Let's move to the next one. That is screening effect or shielding effect. Second one. This is one kind of important effect we can say. Inner electrons screens the electrons in the outer shells from the nuclear attractive forces. That's why this is called a screening effect or shielding effect. Due to electrons, these electrons, what happens, outer shell experience lesser attractive forces from nucleus, which results in the expansion of electron cloud. As a result, atomic size increases with the increase in the screening effect or shielding effect. You see this picture, this green line, whatever we have shown, is inner electron based concept, and blue dot is outer electron. Another picture, if you see screening effect, we have Z is there, the Z is nucleus, and outer electrons is shown, inner electrons also shown. Inner electrons are strongly attracted by the nucleus, whereas inner electron, outer electron repulsions are shown, and outer electrons are kept away by the inner electrons from the nucleus. This is second picture. So what is the relation between screening effect and atomic radius? Screening effect is directly proportional to atomic radius. Very good. Next. See, what is the variation of atomic radius across a period and down the group? Atomic radius size decreases from left to right in a period due to increase in Z effective, means nuclear effective charge, and atomic radius increases from top to bottom due to predominant screening effect over nuclear charge. If you see this picture, this is atomic radius versus atomic number of the second period elements, lithium to fluorine they have shown. It's keep on decreasing up to fluorine. Another picture, if you see, lithium to cesium in the group A, alkali metals, and halogens also, if you observe, from fluorine to iodine. This picture indicates that numbers are increasing from top to bottom in a group when atomic radius versus atomic number graphical representations experimentally given. Okay. Next, what is ionic radius? Another important definition we have: distance between the center of the ion to that point up to the which it has influence on its electron cloud. Actually, it is should be calculated using X-ray analysis. In this, we have ionic radius of one ion can be calculated knowing radius of another one. If you see the picture diagram, in this ionic radius of definitely cation is smaller than anion, so cation is shown small size, anion shown big size. You see the second picture in this one, the blue color is anion and red color is pink color is cation. So if the radius total is there, that is distance d r plus plus r minus. You can also take rc plus re also. Okay, that means what you understand from this picture is the size of cation is smaller and anion is bigger, then it's a neutral atom. So a neutral atom is producing two different ions. One is cation, one is anion. In that case, cation size is smaller than neutral atom and anion size is bigger than neutral atom. Now, you talk about the sizes of isoelectronic ions in which electron number is same but the sizes are different. The reason behind that one is they have different nuclear charges. Now, positive charge size decreases in case of isoelectronic ions, whereas negative charge is there increases and size increases in case of isoelectronic ions. So negative charge is there on anions, positive charge is there on cations. We have very good examples of this type of list of isoelectronic ions from nitrogen to aluminum, anion to cation list given in the left, so from left to right in this order. size decreasing. That means this is a decreasing order of ionic radius. So nitride ion is bigger than oxide ion is bigger than fluoride, Na plus sodium is bigger than magnesium ion, bigger than aluminum ion. Okay, that's it. We'll see in the next session with another important periodic property. Have a nice day. Thanking you all.